And we have viewed airport CCTV security coverage, which shows the left engine detaching from the wing during the takeoff roll.
In the past few days, a shocking video has gone viral, showing a UPS cargo plane bursting into flames and exploding just minutes after takeoff. In the footage, the left engine appears to tear away from the wing, and within seconds, the entire jet turns into ashes. Investigators soon recovered the black boxes, and what they discovered was far more alarming than a simple technical failure. It was a hidden flaw that had silently survived 6 years of regular inspections without being noticed. So what was missed, and how could a tiny crack bring down a massive jet? Stay until the end, because the truth will force us to rethink what air safety really means. On the morning of November 4th, 2025, a UPS cargo jet prepared for a routine flight from Louisville Muhammad Ali International Airport to Dallas. The weather was calm, the sky was clear, and nothing about that morning seemed unusual. Inside the cockpit were 3 experienced pilots who had completed hundreds of flights just like this one. But within seconds of takeoff, something went terribly wrong. Witnesses on the ground saw flames burst from the left wing, followed by a thunderous explosion that lit up the sky. The aircraft tilted sharply, lost altitude, and crashed near a metal recycling yard just beyond the airport's fence line. When rescue crews arrived, they were met with a wall of fire and twisted steel. For hours, firefighters battled to control the blaze, not yet knowing what had caused it. When the smoke finally cleared, investigators began searching through the wreckage for clues. Amid the ashes, they found 2 crucial pieces of evidence: the cockpit voice recorder and the flight data recorder. Amazingly, both black boxes were still intact despite the extreme heat. The data they contained revealed a chilling pattern. The fire alarm had sounded exactly 37 seconds after the pilots applied full takeoff thrust, and the warning bell continued for 25 seconds until the end of the recording. It was not a random alert. It was a signal that something inside the left engine was collapsing. Airport CCTV footage soon confirmed the nightmare scenario. The video showed the left engine tearing away from the wing while the plane was still on the runway. A burst of flame shot out from the joint where the engine connected to the pylon, the structure that attaches it to the wing. NTSB investigator Todd Inman later explained that most of the pylon was still attached to the engine when it fell off. That detail ruled out an external impact or a bird strike. It meant the failure had come from inside the metal itself. When engineers examined the broken parts, they noticed something strange. The edges of the fracture were discolored and uneven, as if the metal had been weakened long before the crash. Closer inspection revealed traces of corrosion and welding seams, clear signs that this area had been repaired in the past. The question now was whether the old repair had failed, or if it had been done incorrectly from the start. Investigators began piecing together a disturbing picture. The so-called critical flaw may have been hiding in plain sight for years, silently spreading through the metal each time the plane took off. To the public, the alarm that echoed for 25 seconds sounded like a desperate warning. But to engineers, it marked the final moment when that hidden weakness finally gave way. It wasn't just the sound of a fire. It was the sound of a structure collapsing from the inside. If the pylon truly broke from within, what exactly caused the metal to fail? And who missed the signs that could have prevented it? The next part of this story reveals how one small crack, ignored for years, turned into a disaster waiting to happen. When NTSB investigators traced the origin of the failure, every clue led back to one place: the left engine pylon. It is the metal arm that connects the engine to the wing, holding thousands of pounds of thrust and vibration every second a plane is in the air. Inside the laboratory, under layers of soot, ash, and melted aluminum, investigators found what looked like an old wound. It was not a fresh break from the crash, it was a fracture line, one that had existed long before the disaster ever happened. According to FAA maintenance records, this same pylon had already been repaired once back in 2019 after engineers discovered a fatigue crack during a standard inspection. That repair was done by ST Engineering, a certified maintenance contractor based in San Antonio. The damaged metal was ground down, welded, and reinforced with a new support plate before being cleared for service. At the time, the job was considered successful. The aircraft returned to duty and flew thousands of hours without issue. But 4 years later, the same part was back in the hangar again. In mid-2021, mechanics replaced several bolts, brackets, and joint components around the pylon assembly. Yet this time, they didn't perform a full ultrasonic scan. Those tests, which send sound waves through metal to detect microfractures invisible to the human eye, were not required by regulation for that maintenance cycle. Instead, the inspection relied on visual checks and torque measurements, methods designed to find surface damage or loose fittings, but not internal fatigue. On paper, the pylon passed every test. But deep inside the weld from 2019, the metal had already started to weaken. Tiny fractures, each thinner than a human hair, had begun to grow with every flight. Each takeoff pushed the crack a little further. Each landing spread it a fraction wider. Over time, those microscopic lines merged into a single fault that would later become catastrophic. By September 2025, the aircraft returned to San Antonio for a scheduled 6-week heavy maintenance overhaul. Crews stripped the paint, checked the hydraulic and fuel systems, replaced wiring harnesses, and removed surface corrosion. Yet again, there was no record of any concern regarding the pylon. The maintenance logs listed no abnormal findings. When the plane rolled out of the hangar, it had passed every FAA-approved test. The signatures were in place, the paperwork complete, and the aircraft was cleared for service. Only days later, during takeoff from Louisville, that same pylon would fail under full power. Metallurgists examining the recovered debris confirmed that the fracture had begun at the very spot where the 2019 weld was located. It wasn't a sudden break, it was the final stage of a slow death that had been unfolding for years. The heat from welding had altered the structure of the metal, making it more brittle than expected. With time and stress, the joint began to separate along the old seam. As the left engine roared to maximum thrust, the weakened section tore apart in less than a second. The pylon snapped cleanly, ripping open fuel and hydraulic lines. Pressurized fuel sprayed outward like a torch, igniting instantly. Fire spread along the underside of the wing faster than any suppression system could react. The pilots never stood a chance. To investigators, the similarities to American Airlines, Flight 191 in 1979 were impossible to ignore. That tragedy also began with a left-side pylon failure, caused by improper maintenance that went unnoticed until takeoff. In both cases, the separation of the engine destroyed critical flight systems and turned the aircraft into a fireball within seconds. The pattern was too exact to dismiss as coincidence. What emerged from the investigation was not a mystery of mechanics, but a story of oversight, of human decisions that stacked up over 6 long years, a crack that had survived inspection after inspection. A plane that had passed every checklist, every audit, and every certification, and a crew that trusted those systems with their lives. The truth, investigators said, was brutal. The failure didn't begin in the air, it began on the ground. It began with a repair that looked solid but wasn't, with a test that was skipped because it wasn't required, and with a system that valued efficiency over absolute certainty. By the time the fire erupted, the fate of Flight 2976 was already sealed. The real question now was not when the plane failed, but why no one saw it coming. Inside the cockpit of UPS Flight 2976, 3 experienced pilots were in control. Captain Richard Wartenberg, First Officer Lee Truitt, and Flight Engineer Dana Diamond had logged more than 30 years of combined flying experience. They had flown together many times, handling storms, heavy cargo, and long-haul routes with precision and calm. For them, this takeoff was routine, until the warning bell shattered the silence. The sound was high-pitched and relentless, echoing through the cabin as the engines reached full thrust. At that moment, they had just 25 seconds to save their plane. By the time the alarm began, they had already crossed V1 speed, the point of no return in aviation. If they aborted now, the jet would skid off the runway. If they continued, they would have to fight a fire in the air. The captain's instincts took over. "Fire, left engine," he called out, his voice calm but firm. The first officer pulled back the throttle and reached for the engine cutoff switch. The flight engineer engaged the fire suppression system, hoping the extinguishing agent would starve the flames. But the warning light didn't go out. The fire kept growing, fueled by ruptured fuel lines. A second later, the cockpit filled with alarms and flashing lights, hydraulic pressure dropping, engine temperature rising, and asymmetric thrust indicators flaring red. The MD-11, designed to fly with 3 engines, was now operating with one side almost dead. The imbalance threw the aircraft into a violent yaw, pulling left with enormous force. The captain pulled hard on the yoke, trying to keep the jet level. They lifted briefly, climbing to about 100 feet above the ground. For a few seconds, it looked like they might regain control, but the left wing was losing lift rapidly as the fire spread across the pylon and melted through key control lines. The plane began to roll. "Hold it! Hold it!" the first officer shouted, his voice captured in the final seconds of the cockpit voice recorder. The recording ended with a short burst of static. Then, silence. Impact followed moments later, cutting off all signals from the aircraft. Experts later confirmed that at that altitude, recovery was impossible. Once the left wing lost integrity, the jet could no longer generate enough lift to stay airborne. The control surfaces, burned and unresponsive, sealed the crew's fate. Even the most experienced pilots could not overcome the physics of a total structural failure. They had done everything right, checklist by checklist, second by second, yet they never stood a chance. The investigation would later show that these men were not victims of human error, but of a hidden flaw born years earlier in the maintenance hangar. The tragedy of Flight 2976 was not written in those final 25 seconds. It was written in the years of inspections, repairs, and overlooked warnings that preceded them. And as investigators replayed the haunting audio of that final alarm, they couldn't escape one chilling thought. If 3 seasoned pilots couldn't save this plane, what chance did anyone have against a flaw no one even knew existed? When UPS Flight 2976 went down, the explosion ripped through the calm morning air of Louisville. The crash site, a metal recycling yard bordered by fuel storage tanks, became an inferno within seconds. Witnesses described a deafening roar followed by a flash so bright it lit up the horizon like sunrise. A shockwave rolled through the city, shattering windows and setting off alarms miles away. For those nearby, the ground shook as if the earth itself had erupted. The plane disintegrated on impact, scattering wreckage and fire across several blocks. Within minutes, flames towered more than 50 feet into the air. People living close to the airport rushed outside, filming the massive plume of black smoke that billowed upward and turned the morning sky dark. Emergency calls flooded local dispatch centers. Firefighters, police, and rescue teams raced toward the scene, not knowing how many people were in danger or whether anyone could still be alive. When the first responders arrived, the heat was so intense that their protective gear began to melt. Explosions from the metal yard echoed like gunfire, sending debris into the air. Yet, despite the danger, crews pushed forward with heavy hoses and foam cannons, fighting to control the flames. What they found was devastating. 14 people had died, 3 crew members on board and 11 others on the ground. Among the victims was 62-year-old mechanic Lou Fedden, who had worked at the yard for decades, and his 3-year-old granddaughter, who had been visiting him that morning. Their deaths became the human face of the tragedy, a reminder that aviation accidents do not only claim the lives of those in the sky. The fire raged for nearly 6 hours before being brought under control. By then, more than 100 firefighters had battled the blaze, supported by airport emergency units and nearby departments from Jefferson County. Teams from the Environmental Protection Agency and the Metropolitan Sewer District arrived to contain over 30,000 gallons of spilled oil before it could leak into groundwater. When daylight broke the next morning, the crash site looked like a war zone. The once bustling industrial yard was reduced to blackened ruins, the earth scorched, and twisted pieces of fuselage scattered across the area. Smoke still rose in thin, ghostly streams, carrying the smell of burnt metal and fuel. Residents gathered behind the police barricades, silent and stunned. Some brought flowers, candles, and handwritten notes, placing them along the fence line where the fire had burned the hottest. Soon, the spot became a memorial. They called it 25 seconds, the length of time between the first alarm and the crash. Mayor Craig Greenberg and Congressman McGarvey visited the scene, praising the bravery of first responders and the unity of local residents who helped evacuate nearby buildings. UPS and FedEx immediately grounded all MD-11 aircraft in their fleets for precautionary inspections, ordering engineers to check each pylon and fuel system. The National Guard was deployed to secure the area while search teams and investigators worked side by side, collecting fragments of the engine, fuel lines, and melted wiring for forensic analysis. For 6 days, the crash site remained sealed as investigators mapped every inch of debris. Each piece was labeled, photographed, and shipped to a secure hangar for reconstruction. Even after cleanup crews cleared the rubble, the emotional scars lingered. Families of victims gathered at the memorial every evening, lighting candles that flickered against the skyline, still stained by smoke. For the people of Louisville, the tragedy changed everything. It was no longer just about a mechanical failure. It was about the fragility of routine, how an ordinary morning could end in chaos and loss. As investigators searched for answers, one question began to echo beyond Kentucky. If one small crack inside a pylon could unleash this much devastation, what would it take for the aviation world to finally change the way it sees safety? In fact, this is not the first aviation accident in the world related to technical errors. Any mistake, even the smallest in aviation, has to pay a very high price. Airplanes are a luxury means of transportation, and users also want to receive the best and safest services. However, there are many unfortunate events that have happened. How many warnings does history need before we learn? That question now hangs over every investigation into the crash of UPS Flight 2976. Because when investigators look deeper, they realize this disaster did not begin in 2025. It began decades ago, through patterns that had already repeated too many times. In 1992, Trans Air Service Flight 671 lost its number 2 engine during takeoff after the pylon bolts cracked under stress. The crew managed to keep control and land safely, but the cause was clear: metal fatigue inside the engine mount. Just 1 year later, in 1993, Japan Airlines Flight 46E faced almost the same failure. The left pylon broke apart mid-climb, leaving the crew fighting to stabilize the jet. And in 2007, Nationwide Airlines Flight 723 in South Africa saw its right engine detach during takeoff. That aircraft also landed safely, but only because it had reached higher altitude before the separation. Each time, investigators warned the same thing: pylon joints on aging aircraft needed stronger inspections using non-destructive methods like ultrasonic testing. Each time, the recommendation faded into the background once the headlines disappeared. NTSB reports from those earlier accidents urged aviation regulators to adopt advanced scanning of pylon mounts, yet the rule never became mandatory for older planes. Visual inspection remained the standard, even though everyone in the industry knew that fatigue cracks usually start deep inside the metal where the eye can't see. In aviation maintenance, a visual inspection means checking the outer surface with cameras, magnifiers, or the naked eye to look for corrosion or distortion. It is fast, cost-effective, and approved by manufacturers for most cycles, but a crack born from fatigue can grow thousands of times before it becomes visible on the surface. By then, the damage is already beyond repair. That is why high-stress areas like pylons, engine struts, and wing spars are often recommended for non-destructive testing, or NDT. Techniques like ultrasonic or eddy current scanning use sound waves and magnetic fields to detect microscopic fractures hidden below the surface. They can find weaknesses invisible to the human eye, but they take more time, money, and trained specialists to perform. For older planes, such tests are not always required. They depend on what's written in the aircraft's maintenance planning document (MPD) or on airworthiness directives (AD) issued by the FAA or the manufacturer. If the MPD does not specify ultrasonic testing for a given part, a mechanic can sign off the inspection after only a surface check. That gap, according to experts, allows old flaws to slip through unnoticed until they grow into catastrophic failures. The MD-11, like the one operated by UPS, was designed in the late 1980s, when materials and inspection standards were very different. Today, many of these aircraft have flown more than 60,000 hours, far beyond what engineers originally imagined. Every cycle of pressure and vibration adds microscopic stress to the same joints and welds. Over years, that fatigue becomes a ticking clock hidden in the metal. After the Louisville crash, the FAA and UPS jointly announced the temporary grounding of all MD-11 jets for a full review of their pylon structures. The order came with an urgent set of proposed measures aimed at preventing another tragedy. First, regulators recommended the mandatory use of ultrasonic and other NDT techniques on high load points, especially for aircraft more than 25 years old. Second, they stressed strict compliance with manufacturer procedures, banning shortcuts such as using forklifts to remove or install engines, a method that had caused deformation in the American Airlines Flight 191 crash in 1979. Third, the FAA called for a digital maintenance record system to track all repairs and inspections, preventing data loss between contractors and subcontractors. And finally, they proposed stronger oversight by FAA-certified engineers, rather than relying solely on reports from outsourced maintenance companies. These steps marked a shift toward proactive safety, one that focuses not only on fixing damage but on detecting it before it becomes fatal. Aviation analyst Mary Schiavo put it bluntly, "The fire on takeoff shows something was wrong from the start." Her words captured the uncomfortable truth that safety is not just about technology or design. It is about discipline, accountability, and memory. Remembering every warning, every investigation, every failure, and refusing to let them fade away. Still, these recommendations are not yet law. They represent a direction, a promise to strengthen air safety before the next overlooked flaw takes more lives. In the months following the crash, regulators and airlines debated how to balance cost, time, and safety in maintaining older fleets. Some argued for retiring aging aircraft altogether, while others insisted they could continue safely if inspection culture truly changed. For the families of those who died, those debates offer little comfort. To them, Flight 976 is not just another case study. It is proof that even one forgotten crack, left unseen and untested, can destroy years of progress in aviation safety. And so the question remains, if one flaw could survive 6 years of inspections, how many others are still out there, hidden inside metal, waiting for history to repeat itself? The crash of UPS Flight 2976 was not caused by chance, nor by the weather, nor by the crew. It was born from a single crack that hid in plain sight. A weakness buried inside metal, passed over by years of routine inspections and forgotten paperwork. Investigators traced every line of failure back to one truth: the system trusted to protect lives had grown too comfortable with good enough. A visual check replaced deeper scans. A past repair was accepted as permanent. And somewhere along the chain, accountability gave way to habit. The result was 14 lives lost and a haunting reminder that aviation safety is never truly finished. Every plane in the sky carries the memory of past mistakes, and every inspection is a chance to rewrite history before it repeats. Flight 976 showed that safety is not just a regulation. It is a responsibility renewed every time a wrench turns, every time a checklist is signed. The crash of UPS Flight 2976 was not caused by chance, nor by the weather, nor by the crew. It was born from a single crack that hid in plain sight, a weakness buried inside metal, passed over by years of routine inspections and forgotten paperwork. Investigators trace every line of failure back to one truth: the system trusted to protect lives had grown too comfortable with good enough. A visual check replaced deeper scans. A past repair was accepted as permanent, and somewhere along the chain, accountability gave way to habit. The result was 14 lives lost and a haunting reminder that aviation safety is never truly finished. Every plane in the sky carries the memory of past mistakes, and every inspection is a chance to rewrite history before it repeats. Flight 976 showed that safety is not just a regulation. It is a responsibility renewed every time a wrench turns, every time a checklist is signed. Because in aviation, as in life, it's not just the big mistakes that destroy us. Sometimes it's the little things we never think about that can lead us to fatal mistakes.